So in this example, we have a piston cylinder system as shown, and we're told that the piston has mass of little mp, and that it's acting under the influence of an applied force F along a smooth horizontal surface. And we're told that the piston is connected by a crankshaft of mass m, connected to a crankshaft of mass mc by a connecting rod of mass m sub rod via pin joints at A and point O. And we're told that the crankshaft is connected to ground via a frictionless bearing at point C. And we're asked to construct free body diagrams for four different variants of the system. That is the piston alone, the crankshaft alone, the connecting rod alone, and the toll system of the piston plus crankshaft plus connecting rod. And as a hint, I tell you in this problem that the connecting rod cannot be modeled as a two-force member. Okay, so with that in mind, let's go ahead and sketch out these free body diagrams. So if I start with just the piston, we know we're going to have the applied force F. We will have the weight of the piston itself, so we'll have mp times g. We will have a normal force acting from the contact with ground N. And then because the connecting rod cannot act as a two-force member, we'll have two additional forces at point A, which I'm going to call AY and AX. And these will be due to the pin joint connection right there. I can now draw a free body diagram for the connecting rod. And so if I do this, at point A, I got to have equal and opposite forces to those acting on the piston. So I'll call this AY and AX respectively. And then at point O, I have to also have pin forces here, so I'll have an OX and OY. And then we'll also have the mass of the rod times gravity at the center, accounting for the weight. Now if I draw a free body diagram for the crankshaft, I'm going to have equal and opposite forces at O, so OX and OY. We have to have forces at C to hold it in place, so I'll call those CY and CX, and then we have to have something accounting for its weight, so we'll have MC times G. And then finally we need a free body diagram for the complete system. So if I sketch in, here's our piston, and our connecting rod, and our crankshaft. I apologize here, let me clean up this drawing, try to make it a little bit better here for you. Our connecting rod and crankshaft. Then the only forces here that I don't need to account for are the internal forces, and so those will be the ones associated with pins. So we'll still have all the weights, so we'll still have MPG, and we'll have mrod times G, and we'll have MC times G. And we need the normal force, which constrains the piston. We need the applied force, which is acting on the piston, and we're going to need the reaction forces at point C, which anchor this thing to ground. So we'll have CX and CY respectively. And with that, we should be good to go. Best of luck as you validate your free body diagrams.